The concept of vectors is a great way to express the position of a point relative to another point in terms of the Cartesian coordinates of the 2 points. Well, let's examine what I mean by this. Let's say I have a vector and it starts at point A with coordinates 2, 3, and it ends at point B with coordinates 6, 1. So let's go over here and find our 2 points. 2, 3, that would be my point A, and 6, 1, that's 2, 3, 4, 5, 6, 1, that would be my point B. And if I were to draw a vector from point A to point B and call that vector F1, F1 is the vector that specifies the position of point B relative to point A. What I mean by this is the initial position of F1 is at point A and its final position is at point B. So F1 is the vector that specifies the position of B relative to A. Well, let's say I have another vector and this vector starts at B with coordinates, of course, 6, 1, and it ends at point C with coordinates 12, 5. So let's find those 2 points, B, 6, 1, and C, 12, 5. It's at this point. And if I were to draw my vector from point B to point C and call that vector F2, what F2 is, it's the vector that specifies the location of point C relative to point B. What I mean by that is the initial position of F2 is at point B and its final position is at point C, just to make things crystal clear. Well, let's write these 2 vectors in Cartesian vector form. F1 would be equal to 4i hat minus 2j hat plus 0k hat. Well, where did I get these numbers? If you think of F1 as the vector that specifies the position of B relative to A, you want to think of this as final minus initial, and this is always true in engineering. So final minus initial, if you look at the x coordinates of the 2 points, final minus initial, 6 minus 2 is equal to positive 4. If you look at the y coordinates of the 2 points, final minus initial, 1 minus 3 is equal to negative 2. Well, let's check this. If you want to go from point A to point B, you want to go 2 in the negative y, and you want to go 4 in the positive x. You want to go negative 2 in the y, and you want to go 4 in the positive x. Let's do the same thing for the second vector. Writing F2 in Cartesian vector form is equal to final minus initial of the x coordinates, that's 6i hat. Final minus initial of the y coordinates of the 2 points is plus 4j hat plus 0k hat. Well, again, let's check this. In order to get from point B to point C, I need to go 6 in the positive x and I need to go 4 in the positive y. 6 in the positive x and 4 in the positive y. Well, if we take one step further, and let's say we'd like to replace F1 and F2 with an equivalent vector called the resultant vector, that vector would have to start at A and it'd have to end at C. And so my resultant vector starts at A and ends at C, and I'll call that the R vector. Well, isn't the R vector just F1 plus F2 in terms of vector? So the resultant vector is equal to F1 vector plus F2 vector. Well, how do I find the Cartesian vector form of the resultant vector? I add the i's up, which is equal to 10i hat, and I add the j's plus 2j hat, and I add the k's plus 0k hat. Well, let's check this. In order to get from point A to point C, I need to go 10 in the positive x and I need to go 2 in the positive y. I need to go 10 in the positive x and 2 in the positive y. Perfect.